Welcome to the second part of the function transformations video. This time we're going to do something more difficult. We're going to do y is equal to negative 2 times 3 to the power of negative 2 in bracket x plus 6 minus 4 minus 2. It is apparent that the parent function is y is equal to 3 to the power of x. We are using subscripts again to avoid confusion. All we're going to do now is finish the table of values for the parent function. Again, we're going to pretend that we don't know how to do any calculations or arithmetic. The only thing we can use is the table from the parent function. We see that 3 to the power of negative 2 is equal to 1 over 9. So if we set 3 to the power of negative 2, open bracket x plus 6, end bracket minus 4, equal to 3 to the power of negative 2, we get x is equal to negative 7. So when x is equal to negative 7, 3 to the power of all of that is equal to 1 over 9. So the y value is negative 2 times 1 over 9 minus 2, which is equal to negative 20 over 9. Now let's develop a formula. We set 3 to the power of negative 2, open bracket x plus 6, end bracket minus 4 is equal to 3 to the power of x1. Then we get x is equal to negative bracket x1 plus 16 over 2. To find the formula for y, we just substitute x back into the equation. So then you would get negative 2 times 3 to the power of x1 minus 2. Notice that 3 to the power of x1 is y1, so y is then equal to negative 2 y1 minus 2. Now we may use the formulas we have developed to solve the table of values for the function. We see that when x1 is equal to negative 1, y1 is equal to 1 over 3 in the parent function. That corresponds to negative 7.5 for the x value and negative 8 over 3 for the y value. When x1 is equal to 0, y1 is equal to 1, substituting into the formulas, we get x is equal to negative 8 and y is equal to negative 4. Now I'll just finish the x values. They're all decreasing by 0.5 because the values for x1 is linear and the function x1 plus 16 over 2 is also linear. Now for the y values, we have negative 2 times 3, negative 6 minus 2 is equal to negative 8, and then 9 times negative 2, negative 18 minus 2 is equal to negative 20. And thus we have finished the table of values. You can graph this if you want. To describe the transformations, we look at the formulas we have developed for x and y. I'm going to start off with the transformations of the x. First, there are two ways of writing the formula for x. You can either write it as before, or bring out the 16 and make it equal to negative x1 over 2 minus 8. Your teacher would probably want you to describe the transformations using the latter value, the negative x1 over 2 minus 8. It makes things a bit clearer. The negative x1 means a reflection across the y-axis. The division by 2 means a horizontal stretch by a factor of 1/2. Lastly, the subtraction by 8 means a horizontal shift of left 8. Now let's look at the other way we could have done it, using the negative and in brackets x1 plus 16 over 2. Following the order of operations, we would evaluate x1 plus 16 first, and that is a horizontal shift by 16 units left. After that, we divide all of that by 2, and that is a horizontal stretch by a factor of 1/2. Lastly, everything is multiplied by negative 1, so that is a reflection across the y-axis. Both ways would describe the transformations. However, your teacher would recommend doing it the first way, where you do the stretches and reflections first and the shifts last. The reason they follow this convention is because the order of the transformations do matter. The stretches and reflections will affect the shifts if it's written after it. For example, if you translate a whole function left 5 units and reflect it across the y-axis, then that is the same thing as reflecting across the y-axis and translating it right 5 units. But the reason our way works is because we have already accounted for the stretches and reflections that will happen if we write the shifts first. Now let's move on to the y transformations. As you can see, the y value is negative 2 times the original y value subtracted by 2. So that is a reflection across the x-axis, a vertical stretch by 2, and a vertical shift down 2 units. If you have enjoyed this video, praise the Lord Xiang Li.